Hi there, this is Vivek. So I hope you enjoyed my previous videos and articles regarding the journey to DevOps. Today I'll be covering another topic, the most important topic, that is virtualization concepts. Many of you may be already working on virtualization, so it's not new for you. So for you guys, it's a refresher, or it's a revision of your whatever you know. And for those who are new to the environment, or those who don't have much information about virtualization, so for them it will be a good informative material. So let's start. Yeah, these are this is the slides that I will be using as a tool for this presentation tool. So let's start with the objectives of today's session. So in my previous articles, I have covered the broad overview of the journey to DevOps. Now in that article, I have mentioned about one of the key skills, that is virtualization. So virtualization is the essence of the modern IT, as well as the cloud is completely based on virtualization. So these are the objectives that I'll be covering today. So today's session will be mostly theoretical, the broad overview of virtualization. So I'll not be covering much demo or presentation on the practical things that need to be demonstrated on a live environment. So that I will be covering later on. So this will be a two-part session. So first part is covering the concepts about virtualization. The second part will cover the demo. So in this presentation as well, I will use some demo just for demonstrating that how the things looks like for those who are new. Okay, let's start. So what is virtualization? So what is virtualization? So virtualization is a process that allows for more efficient utilization of physical computer hardware and is the foundation of cloud computing. Virtualization uses software to create an abstract layer over computer hardware that allows the hardware elements of a single computer, that is processors, memory, storage, and the other hardware components, to be divided into multiple virtual computers, commonly called virtual machines. Each VM, that we call a virtual machine in short, runs its own operating system and behaves like an independent computer, even though it is running on just a portion of the actual underlying hardware. So what does that mean? Like you have if you take into consideration a physical computer or a server. So what are the main components of a physical box? CPU, memory, storage, then graphical user interface, console, network interfaces. Okay, so what virtualization does, virtualization shares these components with another operating system that runs over the virtualization software. So what is that virtualization software or application? That we will cover later on. Now let's proceed further. Yeah, this is the broad overview of how virtualization looks from the architectural point of view. So if you look into it, these are the sorry, just a minute. these are the hardware and the underlying hardware, that is the physical servers over which there is a software that runs. This is called hypervisor. It provides the virtualization capability to the operating system, and then these are the virtual machines. So, running over the hypervisor in the same physical box, we are running 4 virtual machines. So maybe this could be Linux, this could be Windows, this could be any other operating system if it supports, say, let's say VMware ESX. Actually, many of the virtualization software that supports that as well. ESX also is supported, but though we are not using it, the main operating system that runs on an hypervisor is Linux and Windows. Okay, so let's check this diagram. So this is the diagram that's mostly it's released by VMware, shows this kind of diagrams. It shows that clear picture of what the architecture looks like. Like this is a traditional architecture. This is a traditional architecture without virtualization. So without virtualization, it looks like this. This one. Then there is a virtual machine, there is a physical server, over that an operating system, then application. So without virtualization, we install operating system over the server physical box, then over that operating system we run applications, different kind of application. And without a virtualization, what we generally prefer in a traditional mode, like for one application, one server. For every application we use an independent separate dedicated server. So that we are not supposed to mix and match applications. If we run multiple application on an operating system that is running over a single hardware, so it could be possible that the operating system components like libraries and processes collide or interact with each other and create an unexpected behavior. That in order to avoid that, we use separate hardware, separate box for separate application. But in the case of virtual architecture, we use the same box. The same box can be converted to a virtual machine. So how we do that? So over the physical box, we install a hypervisor. Then that hypervisor could be anything, like there are multiple vendors that provide different hypervisor applications. So you can take it as an operating system. Over that operating system, we use multiple guest operating systems. So one could be Linux, the other could be VMware, or other could be Windows, or any other, or multiple copies of Linux you can run, multiple distribution of Linux you can run. Like in one virtual machine you can run Red Hat Enterprise Linux, in the other virtual machine you can run CentOS, on the other virtual machine another one you can run Ubuntu, and at the same time you can run Windows. So with multiple versions of Windows you can run, and these virtual machines communicate with each other using virtual network. So that is called software defined network, that we'll cover later on. So for when, say, if you have multiple boxes, like this is one box. So if you can install virtual machines over multiple boxes, say you have 10 boxes, over that you install six virtual machines on each box. So that will be a huge number of virtual machines. So earlier in a traditional mode, where you were using for say 60 application, you need 60 servers, but here you can run those 60 applications over virtual machines on 5 to 10 virtualization physical box. So that will reduce the costs. So what is the benefit? The cost that where you need earlier 10 around 60 physical boxes, now you need only 10. So this is the way you can configure it. Depend on how many virtual machines you can run on a physical server. It depends on the capacity of the physical server, like how much memory, how much CPU is installed on it. So I hope this clears about what is virtualization. Let's go further. Now let's go through the brief history of virtualization. So when virtualization came into being, while virtualization technology can be sourced back to 1960s. So 1960s virtualization was there. It's designed by IBM. So IBM came with a hypervisor. That is the main application that is used for virtualization. So which creates an abstraction layer over the abstraction layer for the application from the guest operating system with the physical hardware. So 1960s the IBM designed the first native hypervisor, but later on in 2000s it's actually used. The use of virtualization started after or increased after 2000s. The technologies that enable virtualization like hypervisors were developed decades ago to give multiple users simultaneous access to computers that perform batch processing. So while virtualization was originally designed for batch processing. So batch processing, what is batch processing? Batch processing was a popular computing style in the business sector that run routine tasks thousands of times very quickly. So like payroll, this was used by IBM long back. So if we go further, like what are the benefits of virtualization? So let's discuss about the benefits of virtualization. The resource efficiency. Let's take an example that you have one server on which one application is running. So it could be possible that that application is consuming hardly 10% or 20% of the resources. So what do you mean by resources here? Resources means CPU, memory, disk, network cards. So these are the components that we call resources in the case of virtual in the IT infrastructure. So in a physical box, if you are running one application that is using 10% utilization, around 90% of the resources are lying idle. So that's a waste. So that's a big waste. So if we consider that the application would go, the resource consumption of the application would go up to 50% as well, or say 60%, then also we have sufficient resources left that could be utilized for other purpose. So we can install multiple applications on the same hardware, but that is generally not recommended because that creates unexpected behavior if we run multiple applications or different categories of application on a server, because the server is not our personal computer. It's used by applications over the internet by the end users. So we need to consider the performance impacts on the server as well. So in the traditional model, the huge number of resources in the data center remains idle. So if you have hundreds of servers, physical servers running application, running independent applications, so almost all the servers are not utilized fully. So that's a huge loss. But we have to maintain those servers in the data center. We have to pay for the maintenance. Operating expenditure we have to pay for maintaining the data center, those hardware components which are running over there. We need multiple n number of switches to handle the networking, underlying networking. So that becomes a very cost worthy, like it costs huge to the organization. So that is the resource efficiency is one of them. Easier management. So if we run virtual machines over a server, so we can deploy virtual machines very easily using its management interface or using the command line. So every virtualization application does have its own command line. So whenever we need a new virtual machine, we can maintain a template using that for each application. Using that template, we can deploy a virtual machine, or we can maintain a golden template. That is a standard template for a particular flavor of operating system that we use in our traditional mode as well. But in virtualization, so we can use that template to deploy like a virtual machine just within few minutes. If we need to do the installation in case of a physical server, like if we need additional server to be onboarded into the environment, so what's the process? We need to procure the hardware. Then once the hardware is procured, it takes time. When the hardware is procured, it's racked in the data center, it's connected to network. So after that is done, then we install operating system on it. So after installing the operating system, we install the application. So it takes a lot of time. So most of the time, in most of the time cases, it takes around 1 to 2 months for deploying one single server. Because for procuring a server, there could be a huge number of multiple processes that need to be followed, from operations to project management, from finance. There are lots of approval process that need to be followed. But in the case of virtual machine, it's not like that. We are maintaining a golden templates of a flavor of operating system. Using that, we can clone a new virtual machine, and that will complete within minutes, not hours. So that is easier management. Then another example I can give you, like if you need to scale the server, like you need to add memory and CPU on a physical server. So how would you do that? We need to first check whether the particular hardware that supports additional memory or CPU or not. If it supports, we need to buy it from the market. Then we need a downtime to bring the server down, then install it. But if the server supports hot swap, because most of the enterprise class server supports hot addition of like hot plug, which supports the addition of CPU and memory on the fly. So that can be done, but that's also takes time because you need to procure the hardware from the market. In the case of virtualization, the resources are managed in a way as a pool, like there is a storage pool, memory pool, CPU pool. So most of the ESX box, that is the virtualization boxes, physical boxes are configured using a cluster. That part of a cluster, that's the way it's used. It's not like the single hardware is used for virtualization, but in an enterprise level layer, we use a high availability for the underlying hardware hypervisor as well. So in that case, the resources are configured as a pool of resource. Using that pool, we can install the without even downtime, bringing down the virtual machine, we can add CPU and memory on the fly. That's possible. That's possible in various kinds of like different categories of hypervisors. So VMware ESX is one of them that supports it. So let's proceed further. The next one is minimal downtime. Yes, for any maintenance work, just like if you need to add any resource on it, so you can do it on the fly. Then if we need to do any maintenance on the hardware, so we can move the virtual machine to another host. Obviously, the host should be configured with a high availability and the cluster should be there. So we can move it. In VMware ESX, it's called Vmotion. Live Vmotion is supported in VMware ESX. So where you can move the virtual machine on the other host within the cluster. And then you can, once all the virtual machines are moved to another host, so you can bring down the physical hardware for maintenance. So another virtualization that is widely used in the industry is KVM, that's the Linux kernel based virtual machine. So that also supports this hot Vmotion. faster provisioning, that already I have discussed. Let's proceed further. Yeah, how many types of virtualization solutions exist and what all resources we can virtualize. So we can virtualize almost all the components of the IT infrastructure that we use in our day-to-day IT operations. Like, so data virtualization can be done. So data virtualization means different source of data, like you store data in various different kinds of storage in different kinds of different locations. So that you can use to consolidate using software. So using software you can consolidate storage, like the source of data could be different locations, and that you can access it using a single interface. So that you can use. So this is called, and this is data virtualization. So I have an article for this that I will share with you. So if this article gives some more details on it that you can go through. So let's data virtualization. So data that spreads all over can be consolidated into a single source. Data virtualization allows companies to treat data as a dynamic supply, providing processing capabilities that can bring together data from multiple sources, easily accommodate new data sources, and transform data according to user needs. So example, if you take an example like SharePoint, Amazon Redshift provides analytics capability. It stores, it can process and store large amount of data captured from various sources and from a single interface. Google BigQuery is one of them. SharePoint is widely used in the industry. We are also using SharePoint in our environment. So SharePoint provides you to store is a centralized data store there where you can store different files formats like Word, Excel, PowerPoint, or any other formats of data. You can store it in SharePoint, that you can access it over the web interface. Okay, so that is the data virtualization. Desktop virtualization is there. Like desktop virtualization is like a desktop, like we are using a laptop in our environment. So what we do, we are maintaining everything in our laptop locally. If my laptop crashes for any reason, I will lose my data if there is no backup. But in case of desktop virtualization, so workstations are hosted on a data center. That and the desktop that you can use from any of the computer using your laptop or desktop or any physical desktop provided at the office or any kiosk or wherever there is an internet, you can access the desktop over a browser. You can connect to that interface, you can connect to the interface, the desktop interface from anywhere from the internet. So you can get the data from anywhere. You can access your data from any location. So that's possible. So this is called virtual desktop interface. There is one very good product provided by Citrix. So Citrix VDI is widely used. It's a part of Citrix Workspace. So that can be used. That's provided nowadays. Companies are using it. So it's a very good feature. So that is desktop virtualization. The one that we cover deeply, and that is this is the topic, that is server virtualization. This is the main topic of our importance in our DevOps. We need to cover this one, server virtualization. So this is the same we installed the same. This is the same virtualization. Servers are computers designed to process a high volume of specific tasks really well. So other computers like desktops, laptops and desktops can do a variety of other tasks. Virtualizing a server lets it do more of those specific functions and involves partitioning it so that the components can be used to serve multiple functions. Like on the same physical server, you can install a virtualization application, and over that you can run multiple guest operating systems, and then each guest operating system can be used for different purposes. So this is the main virtualization that we are discussing on this in this session. Then storage virtualization we can use. Using this technique gives the user an ability to pool the hardware storage space from several interconnected storage devices into a simulated single storage device that is managed from one single command console. This storage technique is often used in storage area networks like SANs. Storage manipulation in the cloud is mostly used for backup, archiving, and recovery of data by hiding the real analytical complex storage architecture. Administrators can implement it with software applications or by employing hardware and software hybrid appliances. So if you take into consideration the VMware data store, that is one example of storage virtualization. Amazon S3 is another example. Amazon eBay is the elastic block store. Google storage is also SAN storage that we are using in our traditional environment. That is also the same thing. So they are the team that is managing the storage area network. They are using application and application components to manage the disk arrays configured in the data in their devices, storage devices. So that is an example of storage virtualization. Application virtualization. The application virtualization is a process that derives a standard app into believing that it interfaces directly with an operating system's capacities, when in fact it does not. So Citrix workspace is one of them. Like instead of you install all the applications in your laptop, you just have the operating system running over there. Even just you can use a tab as well. You don't need a laptop as well. You access a portal. That portal provides you application components on the as a web interface, and from there you can access. You can use the, just like in Citrix workspace. If you use the Citrix workspace, it provides you web interface that provides you applications like remote desktop. It provides you applications like Word, then Excel, PowerPoint, any of the applications you can use. So that's an example of application virtualization. Network virtualization. This is one of the most important thing in the virtualized and the cloud environment. Network virtualization. What is network virtualization? Network virtualization refers to abstracting network resources that were traditionally delivered in hardware to software. Network virtualization can combine multiple physical networks to one virtual software-based network. So it can divide one physical network into separate independent virtual networks. Network virtualization software allows network administrators to move virtual machines across different domains without reconfiguring the network. The software creates a network overlay that can run separate virtual network layers on top of some physical network fabric. So if you go to this one, like each VM does have a virtual NIC. This physical box does have a physical NIC. That physical NICs are configured, connected to the distributed switch in the data center. So how does these VMs communicate with each other? Does that communicate with the physical switch, or does it communicate within themselves? Yes, there is various ways they can communicate. So let's go a little bit brief brief explanation of how it does. Let's explain it. Let me explain you. Hold on. Yeah. Like each of the virtual machine has a VNIC. Just a minute. Okay, so each virtual machine has VNIC. That is a software-based network interface card. That software-based interface card is communicated with a VMware virtual switch. Okay, so vSwitch, we can say vSwitch. Okay, vSwitch. This vSwitch, so this communicates with V switch, and there is the physical switch. There is a physical NIC. This V switch is connected to the physical NIC. So this V switch is connected to the physical NIC, and from this physical NIC it's connected to the physical switch, distribution switch at the data center. Okay, so this is the way it communicates. So if one VM needs to communicate with the other VM, the communication goes to this V switch. V switch goes to this V switch is since this is a virtual switch, so communication will go from V switch. The traffic will go directly to that VM. So it will not need to cross the physical boundary. So it will not require in a physical environment. If one server need to communicate, the traffic will go to the physical switch, and then move back to the other server. Okay, but in a virtualized environment with a virtual switch, virtual network, it's not like the case. In case there is another, say this is another box. Okay, if there are two boxes, so this is another box. In case this box does have the same virtualization capability, or this virtual machine needs to communicate with this one. So how this is, it's also connected to this virtual physical switch. Now the communication goes to this V switch. V switch does not have information about this one, so the communication goes to this switch, and from this switch it gets the traffic is forwarded to this one, this physical box. This is the way it works. So within the virtual machine to virtual machine connection, the VM to VM connection, the traffic is not required to move out if it's within the same physical box. If it's on a different physical box, then obviously we need to go through the other physical machine. Even nowadays in the modern software defined network, so we have the capability of VMware distributed switch. So distributed switch will communicate two ESX access. The switch spans from one box to another box. If both the boxes are hosted with the same ESXi virtualization hypervisor, so they can leverage that VMware distributed switch. But that's an advanced concept, not required to be covered here. So this is virtual. This is what I have explained just now. It's a virtual network. Okay, let's move forward. So after network virtualization, this is another one. This is another concept, that network function virtualization. Go down. Network virtualization, then network functions virtualization. Network functions virtualization separates the network key functions like directory services, file sharing, and IP configuration, so they can be distributed among environments. Once software functions are independent of the physical machines they once lived on, specific functions can be packaged together into a network and assigned to an environment. Virtualizing networks reduces the number of physical components like switches, routers, servers, cables, hubs, etc. that are needed to create multiple independent networks, and is particularly popular in the telecommunications industry. So once you go through the virtualization in the advanced topics, if you cover, so after that you can go for this network function virtualization, because it's an advanced concept. So it's mostly used in the telecommunication industry. So the packet switching technology they were using in the traditional mode can be now virtualized using network function virtualization. Okay, let's go to the core component of the virtualization. Hypervisor. This is the core component of any virtualization. This is a core application. So this is the application or software that actually provides the virtualization capabilities to the server. Okay, a hypervisor or a virtual machine monitor, you can say, or virtualizer, whatever the name you use, is a kind of emulator. It is a computer software, firmware or hardware that creates and runs virtual machines. A computer on which a hypervisor runs one or more virtual machines is called a host machine, and each virtual machine is called a guest machine. The hypervisor presents the guest operating system with a virtual operating platform and manages the execution of the guest operating system. Multiple instances of a guest or instances of a variety of operating systems may share the virtualized hardware resources. For example, Linux, Windows, Mac OS instances can all run on a single physical x86 architecture machine. So, how many types of hypervisor we have? We have two types. Type 1, that is native or bare metal hypervisors, or type 2 or hosted hypervisor, you can say. Type 2. What is type 1? Type 1 is the actually type of hypervisor we are using in the for server virtualization in our data center environment. These hypervisors run directly on the host's hardware to control the hardware and to manage guest operating system. So, hypervisor of this category is itself an operating system. So, that runs that installs on the hardware, physical hardware, and then provides the virtualization capabilities to run the physical the guest operating systems. So, if you take an example, so what these are also called for this reason, that is, since they are residing directly over the hardware, the physical box, we call it bare metal hypervisors. Okay. So, the example of this kind of virtual hypervisor is Microsoft Hyper-V, Oracle VM Server for SPARC, Oracle VM Server for x86, Power Hypervisor for AIX based systems, and VMware ESXi. It is the most widely used hypervisor application in the industry. That is, VMware is the #1 virtualization service provider. Another one is available, Xen. So, Xen is also a very popular hypervisor. So, Xen hypervisor is actually it's acquired by Citrix. So, it's a Citrix product. So, Xen hypervisor is used by various cloud vendors like Amazon. Amazon is using Xen virtualization in their physical data centers. So, type 2, now what is type 2 hypervisors? Type 2 hypervisors are very small, a light version of a hypervisor that actually runs as an operating system, runs as an application over the standard operating system. Like if we have Windows, so we can use the type 2 hypervisor like VirtualBox is one of them, VMware Player, VMware Workstation is one of them, Linux based QEMU is one of them. So, I can show you the desktop virtual this type 2 hypervisor in my system. If I go to my desktop, so this is one. This is the one. This is a type 2 hypervisor. This is a VMware Workstation where I have two virtual machines running. Okay, so two virtual machines running. So, if you take this one, I have 2 GB of memory assigned to it. I have assigned 2 processors, 40 GB of disk I have assigned to it, 1 CD-ROM drive is there. This is a virtual NIC. This is a USB controller, sound card, printer, everything is assigned. These are the shared resources from my laptop. So, if we need to create a virtual machine, we can create a virtual machine from, say, just you need to create a new virtual machine. Okay, so new virtual machine. So, this is the way we can create a new virtual machine. Say go next. So, here you have to give the image. So, I have given an image. Say next. So, I have to give the details about the virtual machine. Then I can assign CPU, memory, and those components. If you go in, this is a standard, the recommended way, typical. So, if you go for advanced options, so you will get all the opportunities, the what type of virtualization you need to use here. Okay, so what the memory, CPU, so how much memory limitations you can set. So, this is the one. This is a type 1 hypervisor. So I have another one. If you go if you use this Oracle VirtualBox, Oracle VirtualBox is comes as a open source free, so you can download and install. You don't need a license. VMware needs a license, but it does not need a license. So here I have used. So if you look into it, I have 1, 2, 3, 4, 5 virtual machines are created. These first four are actually a CentOS box, where I have configured Kubernetes cluster. This is a Kubernetes, it's completely running Kubernetes cluster. So over it, so the interface is different, but the functionality is almost similar to the VMware workstation. So this is a typical example of a type 2 hypervisor, so which is running over my Windows 10, operating system that is running on my laptop. So for this to run, for any kind of virtualization to run, the kernel, the operating, that is the processor supports the hypervisor capabilities. Like for Intel based, it's Intel VT technology should be enabled, and that's enabled from the BIOS. Then for AMD, so AMD also VTX is required. So Intel VT and VTX is required for AMD. So if the processor supports the virtualization, you can install this and it works. It will work. So, and apart from this type 1 and type 2, another very most popular one, this is one of the most popular virtualization which is used. It's a native, it works natively in a Linux, the modern Linux operating system, mostly Red Hat Enterprise or SUSE or Ubuntu or any of the newer kernel. Along with the newer kernel is natively available. That is Linux KVM, kernel based virtual machine. And RHV, Red Hat virtualization based on kernel. RHV is a Red Hat product. It's a similar kind of product like VMware ESX. So it's based on KVM, falls under this category. It converts the Linux kernel to provide hypervisor functionality and it's integrated with Linux kernel. So we can call this KVM type 1 as well as type 2, because it needs an operating system. This does not need a separate operating system. Bare metal hypervisors like ESX does not need an separate operating system. The hypervisor is itself an operating system. There is no separate operating system required. But KVM is a hypervisor that sits over a Linux kernel. But yeah, if you can install KVM on a standard Linux operating system. If you do that, that works like a type 2, but it uses the kernel's features. Kernel is the main component of a Linux operating system that interacts with the hardware. So it acts like a type 1. If you use Red Hat virtualization, the Red Hat virtualization based KVM, so it's a RHV Red Hat virtualization. It provides a very mini OS and ISO image. It provides that you can install directly on your physical hardware. So that is also a complete Linux operating system, but that does not have the unnecessary software applications installed provided as part of the distribution. So that is a lightweight version, you can say. So you can use RHV, and over that you can use Red Hat Virtualization Manager. There is one Virtualization Manager application that can be used to manage it. So this we can demonstrate it in our next session, or I can show you a short demo of this KVM in this session as well. And in my next part, the second part, I will show you a complete deployment of a KVM over Google Cloud, because I will be showing you how to set up a lab for practice. So where we can run very enterprise class applications, the heavy applications which need lots of CPU and memory, which we do not have in our personal laptops or desktops. So that is the reason you can leverage Google Cloud free tier. So that I will demonstrate it in the next lab. So this is the architectural diagram of a type 1 and the difference between type 1 and type 2. The type 1 is a native one, bare metal. Type 2 hosted. So hardware, this is the physical hardware. Hypervisor is installed, and operating system, guest OS. Different guest OSs are installed over this. And if you take this one, like it's a hardware over that in any of the operating system you installed, and over that operating system you can install an application like type 2 hypervisor, and over that you can install the operating systems. So it adds additional layer with the architecture. So this is a comparison of different enterprise class virtualization service providers. Like KVM is from Red Hat, or it's a Linux based. KVM works on almost all Linux distributions. Zen is from Citrix. VMware is one of the largest virtualization service provider. Microsoft Hyper-V is also a very popular one. So what does this virtualization manager mean? Virtualization manager, this is an application we need when we have large number of hypervisors running over our data center, like around tens of hundreds of machines, physical machines over which the hypervisor is running. So we need to configure them as part of a cluster, so and consolidate all the resources in a single cluster, and to manage those virtual machines like ESX or Red Hat enterprise Red Hat virtualization KVM. So to manage them we need a virtualization, a centralized management application, or you can say an orchestration tool. So that is called the virtualization manager. Or to manage independent ESX boxes as well, or independent KVM boxes as well, you need a manager, virtual machine manager. It could be command line, or it could be a graphical user interface based, or browser based, you can say. So both options are available. So that is called virtualization manager. So when that we can demonstrate in later on when we do the practical lab in the next part, then I can demonstrate it. So now let's get into the KVM. Let's show you a KVM how it works. Okay, so let me this is a Windows box, so KVM I cannot install, and this does not support ESX, so I cannot install ESX on this Linux laptop, this Windows laptop. So for ESX we generally need enterprise class server hardware, but ESX can be installed on a desktop with sufficient memory and CPU. But unfortunately I don't have, so I will demonstrate it in the Google Cloud. So type Google GCP console. Hold on guys, my internet connection is a bit slow. Sometimes it works fast, sometimes slows down. Let's see how much time it will take. I have a free tier account that I can use to demonstrate. I hope you enjoyed the session and found this session to be quite informative. Okay guys, this is the console. So I have to change to another account, because this account does not have the free tier service enabled. It actually expired, so this is another one. So this one does have the its free tier is enabled. Let's see, go to billing. Okay, if you go there, you can see that this is 21,000. It's spending around 30. They are giving around 23,000 rupees free tier credit, so that you can use. So and it's 90 days. It's valid for 90 days. I have now 82 days remaining, and this much amount of is still there. So 21,800 is the credit they are providing, and I have used 21,023. So not much. I have lots of credit available that I can use for my personal lab as well as learning and demonstration. So if you go there, the main components of a Google Cloud that provides this platform as a service, that the virtual instances you can create from compute. This is the compute engine. Compute engine is the main component where from there you can access, you can create virtual machines. So if you go there, if you go open this one, this is the compute engine interface. It's opening. Let's wait. So I don't have any virtual machines running over there. I have deleted it because that's the best practice if you use a cloud. So if you keep the resources running, that will consume your free tier, and if your free tier is used up, they may charge you. The Google does not charge you after the expiry of the free tier account. You have to configure, you have to upgrade the account to a standard subscription, then only they will charge you and you can use further, otherwise it stops working. So okay, so I don't have any instances. So I have an image, I can image this is the VM instances. We can say virtual machine images. I have one machine image. This is the machine image that's configured earlier. So I can use images as well. Machine image is the it's an image of the complete image of the running operating system at the particular point. So it can point and time image of the machine. So you can say snapshot also you can create. Use the snapshot will take it's a point of snapshot will only store the changes happened on the virtual machine, and the image is a complete image. The virtual machine image is a complete image of the image that is done after configuration. So this is machine image. Machine image, this is the machine image, the storage image. Storage image is the image which is actually just like an ISO, so which can be used to deploy an operating system. We are not required to install anything because its operating system is only installed and captured and stored as the image. So we can spin off a virtual machine directly from there using those images. So let's see, create instance, give it any name. So let's say you can give any labels as well for identification, though I don't require regions and zones. Or the regions is the geographical region where the data center is located, and within that region there are multiple data centers are there. These are the data centers. So by default it's showing something. For this lab purpose we can continue with this one. We don't need to change anything. So general purpose, contribute, optimize, different categories of machine family you can use, which provides the higher capacity of resources. Like E2 is the lowest one, which provides the one with virtual CPU and 4 GB of memory. For a normal standard workload for lab purpose, this is sufficient. But since I need to show you KVM, so this will not work for me. So and one most important thing, like this itself, Google Cloud is itself running over virtualization. So when Google Cloud is itself over virtualization, the machine I will be creating, the instance I will be creating is itself a virtual machine. So over virtual machine, you can, if you configure another hypervisor, like I am going to install an KVM, like a kernel virtual machine. Okay, so if you are going to use another hypervisor over the virtual machine itself, then that is called nested virtualization. So most of the cloud providers does not support nested virtualization natively. I am not sure about AWS or Azure, but Google provides the functionality so that you can use nested virtualization. But normal Linux instances, if you install, because that's a pre-installed image, most of the instances or images available on the cloud are pre-installed image. By default, that does not have, the vendor provided images does not have the functionality of nested virtualization. So you need to enable the nested virtualization capabilities in the Google Cloud Platform, that I will demonstrate you in the next lab. So here I have already a pre-configured custom image, so that where the feature is already enabled, so that I can demonstrate you right now without any configuration change. So just take in this one like N2 instance. N2 instance provide a virtualization of like 2 vCPUs, 8 GB memory. It's a medium instance. So there go for, this is sufficient, 8 CPUs and 32 GB. For normal lab purpose, this is sufficient. If you use a bigger one, then you will end up spending from your free credit. So they will charge you from this free credit. Okay, so this is what I have selected, N2 instance. If you go do a course on Google Cloud Platform, you will come to know that what these components are. Right now, this is, since we are just demonstrating a virtualization, I'm not going to demonstrate any of these components. That's out of scope for this. Okay. Now this is a 10 GB persistent disk. It provides a 10 GB disk. At Debian Linux it's showing by default, but I'm not going to. This is actually a vendor provided image. It is using a vendor provided image, so I need to change it to my personal custom image. So if I go there, say if I go to custom images, so if I go to my account, so it's fetching the details from my account. So there is a say nested CentOS 8 image one. Okay, so I'll be using this one. And boot disk type, you can use different on the basis of faster. If you need faster performance, you are going to run any application that needs high performance, you can go for this persistent SSD or standard persistent disk. So or balanced persistent disk, but for me this is sufficient. Okay, so 100 GB, let's keep it 100 GB because this image is configured to use 100 GB. We can increase it, but this is the what I can use. Select. So go there. Here if you go there, so this is the credit you left, and this virtual machine monthly cost will be $230. If you keep it running for the whole month, you will be ending up spending this much. That will be deducted from your this limit. Okay, and hourly rate, they are for every hour they are charging this. Google is charging on hourly basis. So if you run for 1-2 hours, you will be spending few cents only. That's very cheap, not a very high one. Okay, so you can use it. So whenever you need to, that's what I suggest, create a image for your requirement as per your lab requirements, and once you are done with your work, so you can just delete this image and then you can spin off again. So create. So it will take couple of minutes for the installation to complete. Let it complete. Then we'll go further. It's showing that it's creating. Okay, the instance is being staged and will soon begin running. Okay, so here is it's showing here in this location. This is the activity status area. It will show you that it's progressing. So if you click here, it will show the VM instance, MyLab, and its boot disk MyLab is creating. So image, what is the difference between an image and an instance? So image is a file. Image is a file. You can show a standard an image file like an ISO image, where the components are stored as a file. So an instance is a running state of that image. You can spin off multiple instances using a single image. Okay. So when you spin off that image, that will be loaded. It will create a virtual disk from that, it clone a virtual disk from that image and install and start it for you, power it on, and it configures the other virtualization components. And in the back ends they are using KVM. Mostly, I don't know about what Google is using, but Google is mostly using KVM because KVM is the Linux based and Google's data centers are running on KVM on Linux only. So they may be using KVM, or they may be using Zen as well. I don't know. I'm not sure. So at the back end, they are using a standard Linux as well as KVM. So now it's deployed. Now it's showing instance is ready. So This is deployed on zone. This is the data center where it's deployed. This is the internal IP. So every instance which is created on cloud platform does have two IPs. One is the internal IP and another is the external public IP. So this is the public IP, and this is running within the virtual data center, and this is actually an IP assigned to the VPN or the VPC, the virtual private cloud, you can say, which is just like a VLAN in our traditional network. So it's just like a VLAN. So, and they have a firewall, and on that firewall this IP is allowed to access SSH, access the virtual instance to port 22, that is the standard SSH port. So Linux, since it's a Linux, or if it's a Windows, instead if we started the Windows instance, that will allow the RDP connection. So you have two ways to copy the IP and then connect using any of the SSH tool from your laptop, or Google provides a web-based shell. So just connect it. It will be connecting to the terminal of the Linux instance. Okay, so now you are into the Linux shell. So let's be an administrator. Just switch to administrator, root. Now I am root. So let's see the version of it's showing CentOS Linux release 8.3. okay, so this is the platform. Now kernel version, you can see, check the kernel version. It will show the kernel version 4.18.0. it's the latest kernel version. 24.22 is the latest kernel version. It supports nested virtualization. So in this image I have already configured nested virtualization. So KVM is supported here, and also KVM installed. So I am not required to install for this short demonstration. So it's already installed. So how could you check that? So how could you check in a Linux system that if virtualization is enabled or not? So you can check with the extension like VMX extension in the kernel CPU. Get proxy PU. Then it will show filter with VMX. Okay, so it shows VMX. How many CPUs it has? Only I have selected 8. So okay, it shows 8 CPUs. Okay, each CPU is configured with VMX extension. So VMX means virtual management extension. So it supports it. So kernel based virtualization is actually we need by default, even if the operating system supports it, by default the virtualization is not enabled in the server. At the operating system level, we need to install its libraries and tools. So the type of libraries and tools that is used here, so that package that we need to install is libvirt in Linux. Okay. I think the package name is different. Yeah, libvirt daemon is installed already. Libvirt daemon. So libvirt daemon is installed and it's running. Let's see. Systemctl status. Those who are not familiar with Linux, they might find it difficult. Yeah. Libvirt is installed but not running. Okay, so we need to run the libvirt status. Start. Let's see the start. Yeah, it's running now. Now you can use a virtualization. So command line tool is available. So if we search in Google, like KVM command cheat sheet, so it will show you. Okay, so this one, there are many sites available that will provide you the commands. So virtualization, Virch is the tool. This is the tool that is used, the command line tool. Virtual shell, that's called virtual shell, you can use. So which list will show the virtual machines running here. Let's see if we have any virtual machines running over there. Where is the shell gun? Yeah, here. There is no virtual machine installed and running. Okay, so there is no virtual machine installed and running. So we need to install a virtual machine, then only it will work. Now virtual machine installation will take quite a long time, so I need to show something else or some other things, like since this is a Linux instance running over cloud, there is no graphical user interface by default, so you don't have any console for it. But I have already installed the configuration, so let's see if I can access that. I have installed the graphical user interface separately on this, so if I can access it, let's see. So it's showing certificate error. 9090 port is used for, there is a utility called cockpit. That cockpit utility can be used to access the desktop, graphical desktop of that server. Okay. Let's see if it works. I don't remember whether I have configured it completely. I think it's connecting. Yeah, it works. This is the administrative access. This is the administration page of the, actually desktop it does not provide. It provides the administrative page for that Linux instance running over there. There you can use this virtual machine manager, which is provided by Cockpit. Here it's showing that there is one instance available, but that is actually not in running state. It's installed but not running. So we can start it using the Linux shell. We can start it. VIRSH start. Let's see if it works. Started. It's running. Okay. Now you can get the desktop, that is a graphical user interface of this is the guest OS that is running over our nested VM. Okay, so this is running over our nested virtualization hypervisor. So if you expand it, it will show you console. If you go there, you will get the console of that. Let's have a look. It's loading, starting up. The VM virtual machine is starting up. This virtual machine is starting up. Yeah, here it's showing. It will prompt you for login. It will provide login prompt shortly. So hold on. So here you are running. Let's consider the CentOS instance that is running over the Google as the physical box. and this is there is a KVM hypervisor installed, and on KVM hypervisor we have installed another CentOS operating system. Since it's a virtualization within virtualization, it's a bit slow. For lab purpose it's fine, for production purpose it does not work. So it's a complete desktop. Okay, so it's a complete desktop. Now if you need to access the desktop, graphical desktop, just like this one, for the Linux instance that is running over the host, for its host. So this MyLab, if you need to access the graphical desktop for that, by default it's not available, but I have installed it in the image. While customization I have installed it, so you can access that using a normal RDP tool. You need the public IP. So for the public IP, go to here, copy this public IP, and you can use MSTSC, the remote desktop. Just change the IP. Let's see if it works. Actually, MSTSC is for connecting to a Windows box, but Linux, here for Linux we have another option like VNC connection, and XRDP. We use the XRDP protocol for connecting to the graphical user interface. So let's say we'll be back. I'm accessing the desktop over the internet, so it might be a slow. It depends on the speed of my internet connection, and today's internet connection speed is not that much good, but I can see. Yeah, this is it's opening. The desktop is open. This is the desktop of the Linux instance that is running on the Google Cloud, and within this I have configured this as our hypervisor box, so you can take it as a physical box, consider it for now. So if I go there, I can open the virtual machine, the graphical manager for KVM. This is the virtual KVM manager, virtual machine manager. So I have to give a password for the administration rights. Okay, done. This is here you were. This is the virtual machine manager. Using this virtual machine manager, I have already installed one operating system. You can configure multiple operating system using this. You can shut down it. And now if you want to see the hardware configuration of this one, so this will show you the hardware configuration. No, this is for creation, sorry. From here, if you double click on it, it will show you the console of that. So this is the console. This is the console of that virtual machine, the nested guest VM running on this one. Okay, so if you go there, this will show you the hardware configuration. This is the hardware configuration. So how much CPU I have allocated? I have allocated total host CPU is 8. I have allocated 2. And how much memory I have allocated? 409, so 4 GB. 4 gigs I have allocated. There is one virtual NIC, one physical disk. This is the VirtIO disk. This is a format used in KVM. So these are the other hardware, which is virtual hardware. This is all the virtual hardware that is provided, taken from the host VM. It's a shared, all these are shared hardware. So this is the way it's configured. In our next lab, that is next part 2, I will show you how to configure this this Linux instance, how to configure from the scratch, how to configure it, how to enable network nested virtualization, and after that how to install, how to get this graphical user interface, how to access using the cockpit console. So everything I will discuss you there, so that you can create a personal lab whenever you need. You can create an image and keep it with you. You can spin off as many VM instances as you want, but since we have used a higher capacity like 8 GB, 32 GB, you as per the limitation, there is a limitation in free tier, so you cannot create multiple instances. But within this virtual instance, which is within the virtual instance, you can install KVM, and on KVM you can create n number of virtual machines, and you can configure the virtual networking also. You can configure. So everything is possible. Since it's over the network, it's a bit slow. So you can configure everything here. Okay. Virtual machine, edit. Okay, so everything is possible here. So you can say add connections. You can connect to other ESA, other KVM manager, virtual machine manager running on another ESA KVM box, like the physical hypervisor box. That also you can do. Then it will show the resources from both. But this virtual machine manager is for managing independently the KVM boxes. But if you want a centralized management, just like Virtual Center, then you have to use Red Hat Virtualization Manager. Okay, that's a different product. I will see if I can demonstrate that to you as well in the next part too. Okay. So here in that we will configure. So if you go to preferences, we can configure this polling new VM. Okay, general, this configuration console. Okay, everything configuration. Then let's see what other options available. Edit. It's a bit slow. If you go to connection details, let's see connection details. So here virtual networks, you can create virtual network. This is one virtual network created by default. This is using a subnet of 192.168.122, and there is a DHCP server, and it's configured with NAT. So NAT means this guest VM can access internet through network address translation provided from the host operating system, like host VM. Okay, so this NAT is provided. We can create an isolated network for our lab purpose, so that those lab VMs cannot access the internet. That also but they can communicate with each other. So it creates a switch. This is a virtual switch. The default is a virtual switch. You can create multiple switches. You can also configure the host as a router. That's also possible. Everything is possible. Virtual networking is very flexible. So okay, I think this much is sufficient for today, else the video will be too long. Let's winding up. Let's close these connections. So I hope this session proved to be quite informative for you. So in the next session, I will show you some more details on this virtualization and in a practical approach, practical oriented. Okay, so thank you for watching, and I hope this video will help you to progress further. Thank you.